Hey team, it's Mr. Z. Today we're going to talk about lesson 2. Let's go ahead and dive on in. Alright, so we're going to use always, sometimes, or never to complete each statement. And basically, we're going to be referencing some of the concepts we've been talking about. So, if a dilation, that's when you multiply by something, is performed on an odd function to produce g of x. So, f of x being multiplied by some number is going to produce g of x. Will g of x always, sometimes, or never be an odd function? So if I look at an odd function, for example, x, or negative x, or x to the third, you get the idea. So these two, if I do a dilation, will it still be an odd function? And yeah, the idea is that if I stretch it vertically, is it still an odd function? Remember, the definition of an odd function is the end behavior are opposite. So when I stretch it, are they still opposite end behaviors? Yeah. What about horizontally? Yep. So it's still going to be an odd function. It is a always. A transformation, a dilation specifically, will not change something from being odd. If a reflection is performed on an even function to produce g of x, then g of x will be a blank even function. So there's two types of reflections. Negative to the output is going to be g of x, or we can have a reflection, and that will be the new one. The idea is that if a reflection either is performed on an even function, let's go ahead and use our classic example for an even function, a quadratic x squared. So let's go ahead and just reflect this guy. So I'm going to sketch my x and y axis, and I'm going to reflect x squared. And the idea is that negative y. So what it's talking about is negative to the y. Well, positives are over here. I hope you can see that this is a reflection over the x-axis. This is code. This negative in front, -1 times f of x, means reflect over the x-axis. I hope you can see here where negative x is on this side. Here, there's positives. It's being reflected over the y-axis when it's f of -1 times x. That means it's going to be a reflection over the y-axis. This is tools in how you remember what these mean. Build the definition yourself. Do it repeatedly. So let's go ahead and reflect this quadratic over this. It's concave down. Over this, I reflect it, and it's going to be exactly the same because it's symmetrical. Remember, even functions mean have the same end behavior. Okay. Do they have the same end behavior? Yeah. Both reflections will create an even function. So far we've basically determined that if you dilate an odd, it stays odd. If you reflect an even, it stays even.